Assalamu alaikum. I welcome you all to the new lecture on in NS 224 numerical analysis. This is Said Ibrahim, your numerical analysis teacher. In today's lecture, we are going to discuss Regula Falsi method, or we call it method of false position. Method of false position. In this lecture, we will learn the how the scheme is derived for the Regula Falsi method and how it's work, and then we will solve an example, and then we will go toward the drawbacks and advantages of this method. We use Regula Falsi method or method of false position for finding the roots of those transcendental or algebraic equation which cannot be solved through analytical method, or which is very difficult to be solved through analytical methods. So let us start. Before going to the derivation of Regula Falsi method, let us recall some basic concepts about a straight line. As we know that if we have information about any 2 point on a line, then we can find the equation of the line by using the formula y minus y1 divided by x minus x1 is equal to y2 minus y1 divided by x2 minus x1, and this equation will be satisfied at each and every point on the line. Each and every point on the line will satisfy these equation, and this equation can be written as, if we replace y1 by f of x1, we can denote it by f of x1, and as well y2 by f of x2. So we can write it as well, we can replace y by f of x as well, but these equation will be satisfied for each and every point on the line, and we can find the general equation of this line through this formula. Let us see in the second method. Again, we are going to recall a theorem which is intermediate value theorem. In the intermediate value theorem state that if we have a function f of x is equal to 0, where f of x is a real and continuous, the function must be continuous in the interval, and at both on the both the boundary the function have different signs, then there must be at least one root exist. More than one root may also exist. One root must be exist. So let us take a function f of x, where this graph represent this function f of x, and we are behind this root. We are going to find this root where the function is 0 at some value of x. So here we have take an interval where the function have different sign at both the boundaries of this AB interval. We have considered x naught is equal to a and b is equal to x1 or the boundaries of this interval. Let us consider a chord where the chord touch x-axis at x2 is the chord from in the interval from f of a to f of b. So what we do in secant method, in secant method we find the equation of this chord, and then we substitute this point as we have discussed. If we have the equation of a straight line, then it must satisfy each and every point on the line. So if we find the equation of this chord and then we substitute at x2 y is 0, so this point is 0 comma x2 comma 0. So then this chord equation must satisfy this equation, this point, and after substituting this point x2 comma 0 in this chord equation, what will we get? We will get the value of x2, because a and b are the boundaries of the interval, so a and b are known. So as a and b are known, so f of a and f of b is as well known. The only unknown point is x2, and we find x2 with the help of AB. So let us see how to find the equation of this chord. So as in the previous slide we have discussed that we can find the equation of any straight line if we have information about any 2 point on the line. So here at A and B we have information about this line, this chord, where this point is f of b comma f of b, and that one point is a comma f of a. So as a and b are known, therefore the f of a and f of b is also known, and this is the general this chord equation. So let us see, to substitute this point here, y is 0, x is x2 and y is 0. So by substituting this point in this general form of this chord equation, what will we get? We will get 0 minus f of b divided by x2 minus b is equal to f of a minus f of b divided by a minus b. After cross multiplication, taking this term to this side and this term to this side, what will we get? We will get f of a minus b f of b divided by this one term is here, f of a minus f of b is equal to, and we have take this term to the right side, x2 minus b. By taking this b term to the left side, it will become positive and we will get x2 is equal to b minus a minus b into f of b divided by f of a minus f of b. And in the same way, as we have find the value of x2, then what we do, at x2 the function is negative, so f of a dot f of x2 is less than 0. So that's why we will ignore this interval, and next we will find the another chord between f of x2 and f of a, and this chord also touch x-axis at some point x3. Then we will find the equation of this chord, and then we will substitute at this point as well. X3, x is x3 and y is 0. Then by substituting this point value, we will get the value of x3 from here, and as you see, we are getting closer and closer toward the root of this function. So the x3 value relation for x3. So what we are doing in the secant method, first we find the interval where the function have different sign at both the boundaries of the interval. Then what we do, we draw a curve from from one boundary to another boundary of the graph. Then what we do, we find the equation of this curve and substitute this value and find x2 from that relation. Then we again we ignore this interval, because now here at x2 and x1 the function have different signs, and we draw a chord, another chord, we find this chord equation and substitute this value, and we find another x3 which is near, and the same way we go toward the root of the function. So the general form for any function f of x is equal to 0, where the function is continuous in interval a b, and f of a dot f of b is less than 0, then c will be an approximate root which touch the x-axis and near to the root of the function. Now we can find c by using this formula: c is equal to b minus a into f of b divided by f of b minus f of b. This is the general formula. Or by taking my negative sign from here, we can write it c is equal to b minus a minus b into f of b divided by f of a minus f of b. So, steps for finding the root of the function using Regula Falsi method. In the first step, what will we do? We will, for any function, we will find an interval where the function is real continuous, and at both the boundaries of the interval, the function have opposite sign. Then what will we do? We will find C by using this formula, and after finding C, we will find the interval where the function have different sign. So if f of a and f of c have opposite sign, the new interval will be AC, and if f of c and f of b have opposite sign, then the new interval will be CB. And we will repeat this process for our next iteration. And by repeating the process, we will get closer and closer toward the root of the function. In the second iteration, this a comma c is the subinterval of AB, and we will repeat the process, the whole these steps for AC, and then by in the third iteration we will find the subinterval of AC or CB, and we will repeat this process. Let us see in the example how to perform this process. For example, let we have a function f of x is equal to x cubed minus 4x plus 1 is equal to 0. To solve this equation using Regula Falsi method and performing 5 iteration to understand the procedure of Regula Falsi method. So first of all, what we need to do, we need to find the interval where the function have opposite sign at both the boundaries. So the interval where the function have opposite sign is 0 comma 1, i.e. the function is greater than 0 at a, where a is equal to 0, and the function is less than 0 at b. So this is the interval 0 comma 1 is the interval where the function have different sign at the boundaries of this interval. Then what will we do? We will perform our first iteration on AB interval. So C1 will be equal to B minus A into f of B divided by f of B minus f of A. Now here A is 0 and B is 1. By substituting the values, B is 1 and A is 0, and f of B is minus 2 and f of A is 1. By substituting the values of f of B and f of A, we will get this value. And after substituting this value in the given function, we get less than 0 value. So we will replace b by c1 because b is less than 0, and we will get another sub interval of this 0 1 interval, and we will perform the same process for the new interval where a is 0 and b is 0.33333, which is C1. Performing this process for C2, we will get C1 replace B by C1. We will get C1 minus A into f of C1 divided by f of C1 minus f of A. And by substituting these values, we will get 0.257142857. And after substituting these values of C2 in the function, again we get less than 0 value. Now the function is less than 0 at C1, so we will replace the value of C1 on 0.257142857. And by substituting this value in this function, we will get less than 0 value at f of c2. So the subinterval of this interval will be a comma c2. So in the next iteration, or in our third iteration, or interval for the third iteration will be a comma c2, and we replace C1 by C2. So after replacing C1 by C2 and substituting the values in this formula, we will get 0.25420211166. And after substituting this value in the function, again we get less than 0 value. and this less than 0 value tell us to replace C2 by C3. If it is greater than 0, then we will replace A by C3. So here in this situation, f of C3 is less than 0, so we will replace C2 by C3 and we will perform our fourth iteration. And at the fourth iteration, again by substituting all these values, we get 0.25410498845, and by substituting this value in our function, what we get less than 0 value. And again this tell us to replace C3 by C4 for the new for the sub interval to perform our next iteration. So for the next iteration, our interval will be a comma c4, and taking a comma c4 or iteration, we will find c5, the fifth, the approximate solution of the function at the fifth iteration. And you will notice we are getting closer and closer value to the zero. We are getting closer and closer to zero as we are increasing our iteration. At third iteration, we get 0.003 at something value, and at the fourth iteration we get more closer than the third iteration, and at the fifth iteration we get more than closer to the root of the function than the fourth iteration. So it means this we are converging to the root of the function. So at fifth iteration, the approximate root of the function is this one, c5. X is equal to c5 is equal to 0.254101796 is the approximate root at the fifth iteration of the function. So let us see how to perform all these processes using calculator coding. So firstly, to find the interval where the function have opposite sign at the boundaries, in the same way as we have discussed in the previous lectures, you need to press the move button, then press 7 for table, and write your function in your calculator as you have. So we have x cube, so I will write x cube minus 4x minus 4x plus 1. So after writing our function in the calculator, we will press equal button once. What will we get? The calculator will ask you where do you want to start your table from. So I want to start my table from minus 5 up to 5, and fetching my step size 1. So what will we get? We will get from minus 5 up to 5 at the different values of x, the values of function. So at minus 3 the function, at minus 5 the function is minus negative less than 0, at minus 4 the function is less than 0, at minus 3 the function is less than 0, at minus 2 the function is positive. So please note that at minus the in the interval minus 3 and minus 2 the function have at least one root. So one root exists here. If you want to repeat the process for understanding the procedure, so you can take this interval minus 3 minus 2 as well. So at minus 1 the function is positive, at 0 the function is positive, and at 1 the another root of this function lies in 0 1 interval. So I have considered this interval. So you can take one can take this interval as well, minus 3 and minus 2, and he will get the root 2 in this interval by performing this process. And so we have decided to take 0 and 1 to find the root, that one root of the function which lies between 0 and 1, and the another root of this function lies in 1 and 2 as well. So one can take 1 2, so we have take 0 1, so we consider it from here, from this table. So you can find the interval where the function have opposite side signs at the boundaries by just pressing the move button. After move button you will press 7, and then you will write your given function here, and then you will press equal button. You will write or assign to the calculator from where do you want to start, and for up to where you want to construct your table, and then you will write your step size, and then after pressing the equal button you will get at different values of x your function values. Now to write the coding for or procedure for our iterations, so I will press the mode button and I will come to the normal calculator. So now to write the coding for this, what we need to do here, we will substitute or scheme in our calculator. So here what we have b minus a into f of b divided by f of b minus f of a is equal to, and then we substitute the values and we get this value. So I will write this scheme in my calculator same as it has. So I will write b minus a alpha b minus a bracket close. And what do we mean from f of b? So f of b mean b cube minus 4b plus 1. So I will write b cube minus 4b plus 1 divide by f of b. For f of b I will repeat the same function. I will write the same one, b cube minus 4b plus 1, and for f of a I will write a cube minus 4a plus 1. And after writing our scheme in our calculator, what will we do? We will just press the calc button. After pressing the calc button, the calculator will ask you about your value. I will substitute b is 1, so I will write 1 and press equal button. Then the calculator will ask you about the value of a, so I will press 0, and then I will press the equal button. So what I get this value 0.333333, which is 1 over 3. So you can see it, 1 over 3 is 0.33333 and 3. So now to substitute this value in this function, what will we do? We will just press AC button and we will replace this x by answer. So I will write answer cube minus 4 answer plus 1. So after pressing the equal button, we will get this value at C1, the function value, which is minus 0.296296 dot dot dot, which is less than 0. So in the second interval we will decide a and C1. So for the second iteration, just I will press the up button and we have the scheme in the calculator, and then I will press the calc button and just I will replace the b value by 0.3333 or 1 over 3. So I will write 1 over 3, and then after pressing the equal button, the calculator will ask me about the a value. So the a value is same as in the first iteration. So just I can write it or I will just press the equal button. So we will get the value of our second iteration, which is 0.257142857. So after performing this operation, just I will press the up button. So we have the scheme. So after pressing once the equal button, we will get the value of the function at this value, which is minus 0.011568513. And in the next iteration, what will we do? We will just repeat the same process. After pressing the up button, we will get our scheme, and after getting the scheme, I will press calc button and will replace the b value by this value, which is 0.257142851. And after pressing the equal button, the calculator will ask you about the value of a. And after pressing equal button, what we get our third iteration approximation, which is 0.254202. 1 and 6 is rounded here, so we get 117. And for substituting this value in the given function, just we need to press the up button, and just once press the equal button, you will get this value at this point, the function value. And after getting this value, just you need to press the up button, and just then press the calc button and replace b by this value, you will get this value. And in the same way, very easily you will find your fifth or your 10th iteration using the calculator coding. So if you have any problem, so you can contact me through my WhatsApp number or through Google Classroom. Now this is an exercise for you. You need to solve this exercise. Just take it as your homework, and after solving this exercise, you will understand the process very well. So if you have any problems, so then you can contact me. The advantages of this method is, as we increase the number of iteration, we get accurate value of root, or we getting closer and closer to the actual root of the function. And the method does not diverge. It is the man another advantage of this method. It always converge, and it does not require the derivative calculation, as we required the derivative calculation in the Newton-Raphson method. So in this method we do not require any derivative calculation or any other calculation. So it is linearly convergent, and it always converges. The main disadvantage of this method is it may take large time span as compared to Newton-Raphson method. So in Newton-Raphson method we can code the method very easily, and to calculate the root, and thereby slowing the process, as the calculation are so much large in this method. So it slowing the process of finding the root of the function. And the order of the convergency of this method is less than the order of the convergency of Newton-Raphson method. So, in conclusion, as I tell you in the previous lecture, that bisection method and Regula Falsi method are called the bracket method, and the secant method, Newton-Raphson method, and the one other method we have, the iterative method, are called open methods. So in this secant and bisection method, as you have seen, we are bracketing our interval and getting closer and closer toward the root of the function. That's why these methods are called bracket method. And in the other methods, we are not bracketing or interval or something. So that's why the other methods, the secant method, the Newton-Raphson method, and the iterative method are called open methods, and bisection method and Regula Falsi method is called the bracket method, are called the bracket method. See you in next lecture. Thank you for watching this lecture.